In today's lesson, we're going to be graphing linear equations. Remember, linear equations are equations in two variables. So the key idea and the definition is that a linear equation is an equation whose graph is a line. The points on the line are solutions of the equation. You can use a graph to show the solutions of a linear equation. The graph below represents the equation y is equal to x plus 1. Notice there is a y and an x, and we will relate those to ordered pairs that we can graph on the coordinate system. So if the value of x is -1, right here, you can see that y would be 0. And how do you find that? Well, we would substitute in. So using substitution like you did in the assignment last night, y is equal to -1 plus 1. And then you solve that, so you get 0. So this ordered pair, -1, 0, gets plotted on the line. When you extend the line, meaning use a straight edge or a ruler to draw a line through the points that you graph, you can visually see all the solutions on that line. And so I'm going to kind of like point them out, and it's going to be a little hard for me to do on this. But any place that the line crosses the blue grid, where the x and y intersect right here, is when you have whole number solutions. So I'm kind of pointing out a few of them, right? But any point on the line, anything between, right? These are all, I am putting dots at all the solutions, and it's infinitely many. You really cannot describe it unless you're talking about number sets and things like that. However, the ones that fall between the blue grids where they intersect are going to be rational numbers. They're going to be fractional, decimal type numbers. So if at all possible, as we're learning to do this skill, as we're learning to graph linear equations, we're going to try to keep our solutions as whole numbers, or at least integers. Let's keep our solutions as integers. That's a better description, because they could be either positive or negative. So here's example 1. The equation, the linear equation, is y is equal to 3x. This one most similarly relates to what you remember from last year about the constant of proportionality. We know, just from last year, 7th grade, taught you that this is a proportional relationship. This will be a straight line, which makes it linear, and it will go through the origin. So somewhere along the line, we should see the ordered pair 0, 0. So you need to make a table. So this is the type of table I want you to make. I need you to make a table that has a place for the x coordinate, or the input value. In the middle, I want you to write the mathematical rule, and that's what y is equal to. Okay, that's what you're going to be substituting x into in order to solve for y, the output value. The combination of the x and the y will be the ordered pair. I need you to make 5 points. So when we have this, and the coefficient of x is a whole number, right? It could be an integer, it could be any integer, but it's not a fraction or a decimal. I want you to use the following, so you can kind of default always. And the reason we do this is we kind of keep it close to the origin. Okay, we'll have 5 points on the line to definitely test this theory. So we'll substitute in x. So 3 times -2, and then we know the answer is -6. 3 times, and I'm just following this rule as set forth, 3 times -1 is -3. If x is 0, 3 times 0 is 0, and there is our origin. That's our ordered pair, 0, 0. We knew this would happen. 3 times 1 is 3, and 3 times 2 is 6. So I can list my ordered pairs as -2, -6. These are the points I'm going to graph, and if you need help with the graphing, if that was something you struggled with on homework last night, you need to come see me. We have to get you to the point where you can do this successfully. 1, 3. So 5 points on this line. Now you're going to have it much easier. You can make your own coordinate graph on grid paper, on graph paper. I prefer you use graph paper and draw and use the grids on the graph paper to stand for the intersections of the x and y axis. So you just need to draw your x and y axis and then label, count them, with positive and negative numbers. If you choose to submit your homework assignment tonight online, then you will be able to graph online and put this table, again, this table is crucial to your work, on the paper, okay? And then you'll be able to plot it online, similarly to kind of how I'm going to be plotting it now on this graph, but I think it's a little bit easier on our website. So I'll graph -2, -6. Now this is the hardest one because it kind of goes off the grid, so I promise you that online you'll be able to be on the grid. -1, -3. So -1, 1, 2, 3. Okay, 0, 0. And 1, 3. Oops. And 2, 6. Okay, as best I could to get it on a straight line. Again, I'm having difficulty. I can't, online, when you put the dots there, it will draw the line for you. You will be able to submit, or sorry, check your work. You'll check your solution. You're allowed to check it at least 3 times this time. So it's in trying to encourage you to do it online. I'm going to erase, no wonder. That one didn't look right. I need to count. 1, 2, 3, 4, 5, 6. So it's actually going to be right here. It just didn't look right, and now I know why. It definitely wasn't on that line. So I want you to use a straight edge and connect the dots, go through them, draw a straight line. You know that my line's not straight because of the technology I'm using. Let's try another example. In example 2, our coefficient of x is a fraction. In order to clear that fraction so that I'm not graphing decimals, I need to use multiples of 2. Multiples of 2 will clear that fraction. So look at the denominator no matter what the fractional coefficient is. If you use multiples of the denominator, so for this case, I'm not going to use, I can use -2 for sure, but I'm not going to use -1, right? I don't want to use 1. So since I need to have 5 points, I'll start with -4. It's a multiple of 2, right? -2. I'm sorry. It's a -4 wouldn't necessarily be considered a multiple of 2. Let's call it even so that we know we can clear the fraction. Does that make sense? It's divisible by 2. Maybe that's a little bit better description. I don't want to use the words incorrectly. Oops. So again, I don't want to use the 1. I want to use 2, and I want to use 4. So you get to pick the x values, okay? Now substitute them in. So -1/2 times -4 plus 2. And then you do the math, and I'll let you do the math mentally. I'll let you do the math on your calculator, but I do want to see you rewrite the equation with the substituted value. So a negative times a negative is a positive. Half of 4 is 2. 2 plus 2 is 4. -1/2 times -2. A negative times a negative is positive. This will be a positive 1. Positive 1. Positive 1 plus 2 is 3. Anything times 0 is 0. 0 plus 2 is 2. A negative times a positive, however, is a negative. So -1 plus 2 gives me a positive 1. A negative times a positive is a negative, so this will be a -2 plus 2 is 0. So I will be graphing -4, 4, -2, 3, 0, 2, 2, 1, and 4, 0. I'll do my best. So I'll count 1, 2, 3, 4. I'll put down a spot. Always check your work. -4, and we'll actually go up to 4. I'm not happy with that. I'm a little picky. A little better, not much. A -2, 3. Okay, 0, 2, 2, 1, and 4, 0. Hopefully that appears to be a straight line that is going down. So then again, draw your line with the straight edge through the lines. put the arrows on the end to show that it goes on forever, okay? So if you're doing it all on paper, you are making the table, listing the ordered pair, and graphing. If you're doing it online, make your table and list the ordered pairs. You get to plot them on the computer and see the line, submit to check your work 3 times to see if it's correct. After that 3rd time, if you're still having trouble, you'll just have to submit at the end. Only submitted, completed assignments online will count for not graphing on paper. All right, let's try another one. Again, it's a integer coefficient. It's not a fraction. I don't have to worry about it. So I can go ahead and use any values that I want to here, and I'll just stay close to the origin. So -2, -1, 0, 1, and 2. Substitute in. So 3 times a -2 is -6. -6 minus 4 is a -10. And I know I'm not going to have room. I apologize for that on this graph. We'll just have to maybe not plot that point on the example. 3 times a -1 is -3. -3 minus 4 is -7. I should be able to get that one on there. 3 times 0 minus 4. So be sure to draw your graphs appropriate. So you might want to do the table before drawing your x and y axis to make them fit. 3 minus 4 is, 0 minus 4 is a -4. My brain sees numbers. So make sure you're multiplying first. 3 times 1 is 3, and this is 3 minus 4, which is -1. And then 3 times 2 is 6. 6 minus 4 is a +2. So again, I cannot graph this one because it would be too far down, but I could graph the others. But since you're making your own graphs on your paper, you can make them fit, so there'll be no excuses for not being able to graph them. So, -1, -7. And so that barely made it on there. 0, -4. 1, -1. 2, 2. Okay? And then draw your straight line with your straight edge. Okay? The next key idea is the graphs of horizontal and vertical lines. They are still linear equations. Okay? Even if you don't see 2 variables, even if you don't see 2 different variables, right? And I'm going to guide you into making the table and keeping the table format so that you can determine, and eventually you'll get to the point where you'll know that all horizontal lines look like y is equal to a constant. It could be y is equal to 0, y is equal to 1, 2, 3, whatever it could be. It could be y is equal to -10. That would be a horizontal line at that number on the y-axis. So it doesn't matter what x is, because y is always a constant. For the vertical lines, the graph is x is equal to a constant, positive or negative, integer, okay? And it will go straight up and down at that point of x, and as y changes up and down, x stays the same. So let's look at the graph. So this is a graph, x is equal to 1. You may be able to look at that and say, oh, that's great, that's a vertical line. Sometimes, as you're learning this new skill, it's important to make the table so you don't make any mistakes. So we want to do, in this case, if x is equal to 1, think about this. All of your x values are 1. X always has to be equal to 1. There's no math to do here, right? But I can change up my y. I can make it -2, -1, 0, 1, and 2. Of course, staying close to the origin doesn't matter. But when x is equal to 1, look what happens when I go to graph it. It doesn't really matter what the y is. I could graph many, many points because, so here's a 1, here's a 1, here's a 1. Whoop, oh, geez. Talk about messy. It's not much neater, is it? Hopefully you'll see the point. I have very little control when I'm doing this. Oh, goodness. But my straight line, my vertical line, is going right through the x-axis at 1, and it's going straight. It's parallel to the y-axis and 1 place away from it. So I apologize that my line does not look straight in this video. I wish I could work on the technology for you. Okay, so look what happens when you have a horizontal line. In a horizontal line, you have y, in this case, y is equal to a -4. So you can fill in your table with -4 for y. And then it won't matter what x is, right? -2, -1, 0, 1, 2, 20. It could be anything. So you start graphing, you count down on the y-axis when x is 0, y is -4, right? And oh my goodness sake, this is terrible. All these points should be falling on a horizontal line, and again, just by the pressure point of where I'm placing my stylus down, it doesn't really necessarily go in the same place every time. But this horizontal line represents y is equal to -4. Notice that when it's a horizontal line, it is parallel to the x-axis. So think about those types of things as you're working on your homework tonight.